Hi, Lauren.
Oh, hello. Sorry.
No, it's okay. It's perfectly fine. It's just,
Well, um, before, do you have any questions for me?
um, no, but I feel like my only question is, how do I go about, okay, so I just want to know how to go about something because one of my labs, I turned it in and she was saying that like I have a missing page, but I haven't been able to like bring it up to her yet. I tried to go to like office hours this morning and then after
Mhm.
class I wasn't able to stop by. But and especially because today was exams. So
Yeah.
I just feel like how I guess I could just wait after lecture tomorrow and ask. But yeah. So yeah.
Um, Quick question. What was the lab number? What lab number was it?
It was lab number 7 and 6. She graded me pretty hard on this.
Lab number 6 and 7. I could pull those up because I have what I turned in, and I can tell you maybe if you did accidentally miss something, or I don't know.
Yeah,
Um,
yeah.
let's see. So for lab number 6, you should have had the kingdom key that you did in class together. That was the first page of the lab. Then the second page, you this was the classification of bacteria. So this would have been your PAECSASE that you like did the plates for and stuff like that. That would have been that dichotomous key. So that
Oh,
would
so
be
we had to have two dichotomous keys?
yes. There was the
Okay.
animal kingdom one, and then the like the one that you did. It was like, does it grow on an EMB? And then you could separated out the 4 bacterias into 2 and 2, and then you said, does it ferment mannitol? And then you could get a definite a one between S. epidermidis and S. aureus.
Mhm. Okay, that's what
I
I'm
think
missing.
that was the one you were missing.
Yeah, I'm missing that one. So I don't exactly know where it says to do that.
So if you take a look at your lab manual, it says lab 6 bacterial identification and flow charts. On the bottom of that page, it says the 5 kingdom key, and that's where you draw that one. And then on the next page, it says using flow charts for classification of bacteria using lab 5. And in that big box, it should you should have drawn the create a simple dichotomous key identifying bacteria using the information from lab 5 where bacteria were identified based on growth on specific media.
Okay.
So there should have been 2 dichotomous keys total, and then you were able to use Berge's keys on the second part of the lab, and that was identifying the 4 different organisms. Right?
Mm-hmm.
And then for lab 7, let's
I have a question. I'm sorry.
Yep. No, go
So
on.
when she asks for us to identify, what does she mean by that? Because I just was identifying like I just would put like staff or what I thought it was, but I just was like it needs to be more. Like that's what I was talking to my tutor about. I was like, I think there needs to be more language in
Yeah.
identification, not just one thing. Yeah.
So why don't we look at organism number 4 if you want to open up lab 6 if everybody wants to. So organism number 4. Let's look at what we have there, right? We have a gram-negative bacillus. And then we look at the lab tests. It says positive for glucose and lactose fermentation in a TSI tube. The oxidase test is negative. The indole test is positive, citrase test is positive, and after 48 hours, the VP test is negative, MR test is positive. So if we go to our Berge's keys, first of all, we know it's a gram-negative bacillus, right? Gram-negative rod. So let me see. So if we go to our gram-negative rod page in our Berge's keys, It's going to be, if you're counting the first page where it says some examples, Gram-Stain and morphological flowchart, that's going to be page 1. Back of that, page 2, 3, 4, 5. It'll be page 5. And it should, here, let me bust it out. This is what the page should look like that you're starting on.
Okay, I see that gram-positive rod.
Yes. So we start at the top of that one, because remember, this is a dichotomous key. It's going to be, what is it? Yes or no. So the oxidase test for this bacteria, it said in the lab test that it's negative. So we're going to go to the right. So we're going to go to the Enterobacteriae chart, and that's just on the next page. It's just on the back side. So if you flip over the page and you see the family Enterobacteriae, we're going to see that the next question is lactose fermentation. So we saw glucose and lactose fermentation. So it's going to be positive for that. We have this whole long list of bacteria. So next test we're going to do is the indole test. The indole test under this organism's lab test is positive. Okay, we're going to go to the left. Then we have a smaller amount of bacteria. Next is the citrate test, and that is positive. So then we have 3 bacteria it could be. So now underneath each one, instead of continuing the dichotomous key, it's going to say VP negative and H2S positive, VP positive and H2S negative. So we know that this is VP test negative, right? And the only one that is VP test negative is the Citrobacteria diversus underneath there.
Okay.
So do you see how I got that?
It was kind of a lot, and I feel like I did get lost throughout the process. But I just don't even know what page we're on. But yeah, I'm understanding more every time it gets explained to me. But yeah.
Okay, that's good. So the basic thing is just looking at as much information as you can get and making a list out of it. And then starting with, all you really need to start with is the Gram-Stain, and if it's a cocci or rod. And then you can start on that one page, and it might start in one box, and then right underneath it, it's going to be basically a yes or no question. If it just says indole test, it's either positive or negative. So you don't really need to know what the indole test is yet. You just need to know the properties that this bacteria has, right? So when you're going through it, it should be in the lab, like the lab tests. And if it's not, you're in the wrong spot for at least lab 6. So if you wanted to like double check your answers with me, or if she said, oh, this is wrong, try again, you can try again and see kind of what it's supposed to be against the answers that I have.
Okay. Okay, thank you, Lauren. I will be reaching out for that because yeah.
Yeah, no problem. Yeah. Also, one other thing for lab 7, did you attach a graph?
Did I? No. So that.
Did you? Okay, so that was the other page you were probably missing for lab 7. There was a little section for lab 7. It's if you look at lab number 7, and you have the first info page, the second info page, and then it says on the third page, lab exercise 7, microbial metabolism. And then you see your results for the tube, your AG, K. You see that little chart that you filled out. Underneath there, it says the data below shows the pH changes in glucose phenol red broth over an 8-day time frame. Create a table and graph in the computer. Attach the table and graph completed in a software program in order to get full credit on the lab. So she
Okay.
just said that you didn't really need to do like it on the computer, but you did need to attach a graph. So you just take that, you label your X, your Y, you make a title, and you graph the points.
Okay. I think that's like extremely helpful. Like just what you've told me so far, I should be able to help me myself by reviewing this again and getting
Yeah.
points back, hopefully.
Yeah.
Yeah. So thank you.
Yeah, no problem. Does anybody else have any questions? I know it's kind of if you already took the exam, props to you for coming today. I mean, man, I would be brain dead. Okay. Um, but yeah, uh, let me see something. Well, I did want to show you guys one thing. Let me go ahead and share my screen. This isn't related to micro, so if your brain needs a little break, here it is. I wanted you guys to see, this is Dave Seymour, LMFT. He is a great resource that we have on campus now. I don't know if you guys have heard, but we've actually gained 2 licensed therapists on campus. So they're available for you, completely free, confidential. If you feel like stress is getting to you and you need to talk to somebody, even if it's like, you know, it doesn't have to be so extreme as to where, you know, your life is at risk. It doesn't need, like, if you think, oh, well, I'm taking away from somebody else that has problems like that, you're not. It could be as simple as, you know, I'm feeling like I'm burning out. He has some resources for you online here. This says for sleep, study, meditation, ambient background. If you want to play that right now or play it after this when you're studying, that's great. He has a few meditation, like walkthrough ones. But he's a really great resource if you do think that you need to lighten your mental load. He's on campus, and I believe that here I have notes because I've actually personally talked to him, so I'm not just mandated to tell you guys this. I really think he's a good resource for you guys if you need the help. Okay. So you get 6 sessions a semester. You can call the student health office and schedule an appointment. Here, let me leave their if I could do the chat, please. I'm gonna leave the Office of Student Health Center's number. 395. Okay, that's the Office of Student Health. And what'll happen is you'll try to schedule an appointment. They'll send you an email and you have some health forms to fill out, but it's nothing too serious. I had to do it for a physical and a TB test, and it took me maybe like 10 minutes. And the Student Health Center is, you guys are probably at least halfway familiar with the Levinson Hall. It's basically the number's in the chat. The student health number 661 395-4336. But if you're by the bookstore and you're walking towards the library, keep going past the library and make a left, and that's the Levinson Hall. They're in there. There's a bunch of signs to direct you. But his YouTube is a great resource for you guys. Just like sometimes I'm so stressed out, I don't want to do it anymore, and you have to throw up your arms. Whoa, low pH denature proteins, right? I will get back to that, but yeah, that was my little spiel on Dave. And he has some great advice, and I really encourage you guys to go over to him if you guys need the help, okay? You're okay. So yeah, if you guys have any questions about Dave, if you guys have any questions about any material, I can help you guys. Yeah, if you guys want to type it, or you guys can unmute yourselves. It's up to what you guys feel. Well, let's see. Um, I'm gonna see. I wrote down a couple of things that were asked of me. I did send some old recordings. I hope those help if they were things that we've previously gone over and maybe just needed a little extra help or whatever it might have been. Okay. But yeah. Do you guys have any questions? Not at all? Not even like a topic that you feel iffy on? Do you guys need some advice? I don't know.
Can we go over some of the stuff on chapter 5 with
Chapter.
respiration, fermentation, and is it electron transport chain?
Yeah, of course. Here, let me pull chapter 5 PowerPoint up real quick. Also, do you guys did you guys see that picture I sent out of the glycolysis and the sorry, glycolysis to fermentation or respiration? Do you guys see that picture I sent out?
No, but I'll look right now. I'm gonna see. I want to see it. I'm gonna see.
Did it go through? I sent it out kind of in the evening on Monday. Yeah, I think it went through. Sorry if I spam you guys, by the way.
Oh no, that's a really good overall picture.
It's professor approved. I texted it to Dr. B and I said, is this good? Just to double check. But keep writing that down until you can write it down in your sleep. And then anytime a question is asked of you about any type of metabolism, draw it out on your page and reference it. I promise you it's going to be easier than trying to commit it to memory to a point where you have to, like, if you're asked a question, you can just recall it, you know? Because who has the brain capacity for that if you have 30 different images like that you have to memorize?
Right, instead of having all of them separated, now you have it all together.
Yes. And if you're the type of person that kind of gets lost in the thoughts, or maybe you confuse one step versus another one, it's really helpful to, yeah, no problem, Ling Ling, have a good one and a good luck, okay? But it's really helpful to draw it out. That way you don't lose track of where you are.
Okay, yeah.
But if you would like me to go over that, I can. let's see. You guys know autotroph, heterotroph, chemophoto. Let's see. And then you guys remember from chemistry probably the oil rig, right? For the redox reactions. Oxidation is a loss, that's oil. And then reduction is a gain, that's rig. And then for catabolism, you'll need to know the difference between these two 100%. Sometimes I think of like, you know, like cats, let's say you have a cat, right? And they like to claw the side of your sofa because they have too much energy. They're releasing the energy by breaking down your couch, right? That's how I think of catabolism. Anabolism is like, Anna's a tired college student and she needs the energy. Like she needs the coffee, right? That's how I kind of think of that. If you guys have better ones, feel free to share, but know the difference between these two. Let's see. Then the oil rig here. And then you guys understand, did you guys want me to go through the electron transport change a little bit?
Yes, please.
Okay. So part of that is the concept of NAD to NADH and FAD to FADH too. So, oh, I got a chat too. Oh, Anna from Frozen as she builds a snowman. Yes. Alrighty. But for the electron transport chain, they are like batteries. So by charging them, you attach that hydrogen and you deplete them once that hydrogen is lost. The energy is in the hydrogen. Don't get confused with the charge all of a sudden becomes positive for the compound when it loses the hydrogen. That is something completely different. We don't want to think about that in terms of metabolism. It's the fact that it's a carrier for that hydrogen and that we can cleave it, release energy, and use that energy in the cell. That's kind of the concept of those two molecules in aid of the cell gaining energy. Let's see. I hope the next. Let's see. And then enzymes, we know. Memorize this, draw it out. Man, where is it? Oh yeah, okay. Another thing before we move too far, memorize this, or at least know these and understand the concepts behind them. I'll just point that out momentarily. Okay, we know about glycolysis, fermentation. Okay, here we are. So, right, we've gone through glycolysis. We've gone through the synthesis of acetyl coenzyme A. We've gone through the Krebs cycle, and now it's time for the electron transport chain. So, in bacteria, this happens in the plasma membrane. Sorry, cytoplasmic membrane. And in the cristae of mitochondria, right? So that's the two places where this happens. And remember, mitochondria is for the eukaryotes, cytoplasmic membrane is for the prokaryotes. Let's see. So we obviously, for the electron transport chain, we need the phospholipid bilayer, right? And we know what that looks like, right? We have the hydrophobic heads or the hydrophilic heads and the hydrophobic tails. And it's this whole kind of like cascade, right? Let me get this bigger picture going on, right? So our products from the Krebs cycle include a whole lot of NADH and some FADs, right? So we pump those into the, I want to say carrier proteins. Let me double check that. Yes. So they're going into the carrier proteins, and then when they break the hydrogens off of those molecules, it's releasing energy, and the hydrogen's being pumped out of the cell or out of the area, right? So when we pump the hydrogen out and we return the NAD or the FAD back into the cytoplasm, we are creating a electrochemical gradient, right? The outside of the cell is positive, the inside of the cell is negative. We pump the hydrogen out and the electrons stay within the membrane, and they just keep traveling down until they finally combine. And remember, this is aerobic respiration that we're dealing with. So when it's aerobic respiration, we have the presence of oxygen, those two hydrogen molecules from outside of the membrane. Remember, we pumped a bunch of those out, so two are now coming back in and combining with the oxygen for the aerobic respiration, and they're going to gain some electrons, and then we're going to push those out, right? Part of this whole process is the, what goes in, what goes out. And when we also bring hydrogen through, it's going to it's going to have an effect right here, right? So the ATP synthase, it's going to go ADP plus P and create ATP. That's part of the that's part of this process here. And then if you look down here, this is why I always recommend downloading the actual thing, is because her lecture notes are right here. If she's going to talk about it, it's going to be down here. And not only that, if she's going to talk about it, it's going to be on the exam. So if you're more of a reader, this is where you need to go. So remember, this is the gradient I was talking about. Remember where they're located. The whole concept of donating hydrogen atoms to the carrier proteins. And then we push those hydrogen out, remember? Let's see. In some organisms, remember, not every organism does aerobic respiration, but it's an oxygen atom that creates water, or H2O. And this is what aerobic respiration, they're called aerobes, right? And then this is also another point. Other organisms called anaerobes use inorganic molecules instead of oxygen as the final electron acceptor, and they perform anaerobic respiration. But yeah, so if you want to know more about, hold on, I gotta check. Would you say that hydrogen coming in are active transport? Good question. I'm going to say no. Hold on. So let me see here. Okay, I was wrong. So it says right here, energy from each electron passed down the chain is used to pump protons from one side of the membrane to the other. So it's not traditionally a active right, an active transport, because usually active transport is going to be ATP, right? That's pumping it in. It's going to use that type of energy molecule, not just the electrons. So this is a special type of active transport. But if you were to say, like, if you were to be asked on an exam, what's an example of active transport? I would not say the electron transport chain. It's one of those things where it's like the gray area in biology. So yeah, there's also this part of it. It says that there's a lot of potential energy created. So there is energy there, but it's not being used in a, oh, no, you're okay. You know, the whole thing, most of this class is taking one concept and being able to connect it to another and critically think about it. And doing that while you're trying to listen to lecture is going to give you a better opportunity to try to visualize what might be on the exam. So you're thinking the right way, and it's always good to ask those questions. But yes. So let's see. I just want to make sure I cover. And then remember how many are made, right? How many are made? How many molecules of ATP is made from the electron transport chain? And then this is a good little summary chart if you like charts. I also wanted to, there's one other chart I wanted to show. I don't know if I can find it. Okay. It looks kind of like this, and it says the different types of respiration. Okay. So is that pretty good on the aerobic portion, the electron transport chain?
Yes, thank you.
Okay. And if I didn't explain it right, or if I didn't explain it the way you needed to hear it, please tell me. I'd rather have that happen than you just be like, I'll figure it out, and then I don't know.
No, I needed help seeing like kind of how it flows. And then also the other picture that you posted kind of helps me a lot, because remembering where everything is at and how it flows into one another is like the complicated part.
Yeah. And I will say that I basically just simplified, let's see, it's this but bigger. This. I basically just simplified that.
Okay.
But yeah. What I'm gonna do really quickly is I know I just threw quite a bit of information at you guys. If you didn't get a chance already, maybe jot down the oh no. But I'll really quickly jot down that number for the Student Health Center. I'm going to give you guys a quick break. So I'll give you guys 5 minutes. So be back here at 7:42 to get the full 5 minutes. Be back then, and think maybe of a couple more questions you'd like to ask. And if there's anything you're confused about, or if there's anything maybe you missed class for, you don't understand fully, or you don't feel like you know in depth enough. But go ahead, get some water, take a chill pill. I know you guys probably have some kind of chocolate laying around from Valentine's Day, so go on, relax for a minute, and I'll be back, okay?